Hello again, this is Mr. Solis from Advanced Quantitative Reasoning. I'm talking about, let's see, probability in games. This is a particular video game. I changed the what the game is all about. Victoria is playing a new video game with the objective to find hidden treasures. To do so, she must travel through several levels, clashing with guards and watchdogs. One part of the journey, Victoria must pass through two gates, Gate 1, Gate 2, to get to the next level. Okay, and so this is where I change it. The chance that Gate 1 is open is 20%. If it is closed, she must do battle with some kind of dragon or something like that. Anything that's going to make the game difficult. But to go ahead and curb the difficulty, I put in this little thing. If it's open, then you don't need to go ahead and kill the gate guard. But if it is closed, a gate guard must be defeated. So the chance that Gate 1 is open is 20%, and the chance that Gate 2 is open is 30%. If the gates are open, no gate guards. But if it's closed, if any one gate is closed, then you have to battle one. The designer had programmed the gates so that the probability of both being open at the same time is 0.1. Now, this is actually supposed to be 10%. They didn't put that in right, but no, that's the way it is. Now, you can use this in several different ways. You can make a Venn diagram, which, is pretty simple. You have the opening of the Venn diagram like this. Two circles. Gate 1, Gate 2. Now, Gate 1 is open 20% of the time. So this represents the time that the gate's open. Now, Gate 2 is open 30% of the time. Now that's a total right here. And you find out that both of the gates are open 10% of the time. So right here, instead of 20, 20 minus 10 would be 10. And 30 minus 10 would be 20. So that tells me what this is all, what percentage these are. The probability that Gate 1 is open, only open, is 10%. The probability that Gate 2 is the only gate open is 20%. And the probability that both of the gates are open is 10%. Now, if we add this all together, that's 40. And we're going ahead and getting this out of a total of 100 minus 40 would be 60. So 60% of the time, both gates are going to be closed, and you have to do battle with two different gate guards. So that's where the difficulty of the game is. So we run into a little bit of luck and something that'll go ahead and have this happen. Now there's a couple of questions here. What is the probability that both gates are open when Victoria reaches this part of the game? Well, that's 10%. What is the probability that only one gate is open when Victoria reaches this part of the game? Well, let's see. Only one, Gate 1. Okay, so we're talking about only Gate 1, so it's also 10%. This is because right here, this is the percentage that the Gate 1 is only the one that's open. Okay, what is the probability that only Gate 2 is open when Victoria reaches this part of the game? Well, that's 20%. What is the probability that neither gate is open when Victoria reaches this part of the game? Oops, I'm making this. That would be 60% of the time, because this is when both of the gates are closed. So 60%. What's the probability that Victoria finds exactly one gate open? So this is either one and only one. So this is either Gate 1 or Gate 2. That would be the probability of this one. Now, we look at the probabilities right here. Gate 1 being open is 10%. Gate 2 being open is 20. And only. So 10 plus 20. That's equal to 30% of the time. Alright. So what the point is that we can't is coming up with these percentages. It's very easy with the Venn diagram, but you could also do it with a tree diagram. But you know what, let's go ahead and come up with a picture for the tree diagram. So we go like this. This is open, close. Then of course we have two more, open, close. This part of the tree stands for gate 1. This all just stands for the choices at gate 1. Once you go ahead and get to gate 1, you only have two choices, open and close. At gate 2, it can also be open and closed, but it depends on what happens beforehand. Open, close. Now, we said inside of these notes that 20% of the time right here that gate 1 is open. So that would stand for this, 0.20. That's open. That means that 0.8% of the time it's closed when you get there. So there we go for that one. Now, the chances that both of the gates are open is 0.10, or 10% of the time. Now this is where we're going to have a little bit of math. So we just start thinking, alright, what is this number right here? What do I multiply 0.20 to get 0.10? So remember, you take these two right here and you multiply them. So 0.20x is equal to 0.10. Then you solve for x. 0.20 divided by 0.20. That gives me x equal to 0.50. So instead of putting 0.5 zeros right here, this is also 0.50. Because remember, these two have to add up to 1. So 0.20 times 0.50 is equal to 0.10. So that's where we get these two numbers, and so that's where we get our probabilities. Now we're going to go ahead and use the next one. So I'm going to find out right here, the probability of both of them closed has to be 0.60 because 60% of the time it's closed, as demonstrated by our Venn diagram. So now I want to find out what this number is. So 0.80 equal to, times x equal to 0.60 divided by 0.80. So let's see, 0.60 divided by 0.80 would be 75. 75%. And then of course this would have to be 0.25, so the ending probability that we're going to end up with a closed open would be 0.8 times 0.25, 0.20. Alright, so that's how you would get those if you wanted to use this use the tree diagram. Tree diagram is a little bit more difficult. I prefer using the Venn diagram, but finding out your probabilities is a little bit more difficult with that. Okay, oops. Don't worry about this. I was just drawing it. Alright, so that's a bit it for that. And then next, we have another little thing. We have a new little challenge game according to Victoria's stuff. So let me put this right here. We also have a new challenge game. Victoria encounters another challenge in the game. If she zaps a target in one try, Victoria gets a chance to capture a bonus shield. Now, I don't know how good, well, it says how good of a shot she is. So, let's see. Gotta look at that. Alright. So, let's see. So we have this particular thing. Victoria counters a game. If she zaps the target in one try, Victoria gets a chance to capture a bonus shield. To capture the bonus shield, she must hit the second target in one try. She can hit a target in one try an average of 60% of the time. So that's the interesting thing about this one. This one's actually easier to use the tree diagram on this. So I'm going to draw the tree diagram of her first shot. So this is shot number 1. So she either hits it or she misses it. Now, she has an average chance of hitting it 60% of the time. That means 40% of the time she misses it. Okay? Now, if she hits it again, this is for if she hits it again, she gets the bonus shield. Whoops. Misspelling. The bonus shield. So, it's still the same probabilities. 0.60, our 60% of the time. Let's get rid of that. She'll hit it, and then 40% of the time she'll miss it. Alright, so what's the end probabilities? So you just take 0.6 times 0.6. This is going to give me 0.36. She has a probability of getting 2 hits, 36% chance. So this is 36%. So she has a chance of getting this at 36%. Now, the percentage of her missing it is a little bit more, or a little bit different. 0.6 times 0.4, that's going to be equal to 0.24. So this is a probability of her hitting it and then missing it. 0.24, which is equal to 24%. Now, over here, it doesn't matter. Once she loses the chance, that's it. She's done. This actually leads over here to another one. So, 40%. So, she has a 40% chance of hitting it, or missing both, missing the first time. And that's it. She doesn't get any more chances. She has a 24% chance of hitting it and then missing. And she has a 36% chance of hitting it twice. Alright, I hope you will enjoy this, understand it, and we'll talk about this in class. See you guys.